Alright, well, this is some holiday bonus calculus information. Um, and let's take a look at a few things. First of all, I would like to remind you that the integral from a to b of f of x dx is equal to negative the integral from b to a of f of x dx. Keep that in mind. Some of you, that will greatly help out. Okay. Now, our next little idea. Let's say that we had an integral that went from 2 to x. And it was something like t cubed. Not t cubed. Let's just go t plus 3 dt. And we wanted to evaluate this thing. Well, the antiderivative is 1/2 t squared plus 3t. Oh, and by the way, just because we have u substitution doesn't mean we need to use it. And we could evaluate this thing from 2 to x. Well, what does that mean? It means wherever we see a t, we're going to put an x squared, or an x. We have 1/2 x squared plus 3 times x. And then we're going to subtract 1/2 times 2 squared plus 3 times 2. Well, 1/2 x squared plus 3x, right? Because x is a variable, we don't know what it is. And 3 times 2 is 6. 2 squared is 4. Half of that is 2, so we get -8. And that would be done. Okay, that would be the correct answer. All right. Now, let's see. What else could we talk about? Let's see. Let's say that we had a graph. And we had a set of axes that looked like this. Okay? And just for fun, let's say that our graph looked like this. Something like that. Okay? And let's label a few points. Let's label this thing A, this B. Let's label, well, let's call that 0. And let's call that C. Some x values. That's what we're interested in here. Now, if I wanted to estimate the integral, and let's say we called this f, the integral from a to b of f, let's call it x dx. Remember, that integral represents the area between the graph and the x-axis. So it would be this kind of red shaded region here that I've got. Okay? Now, we could count squares, we could break this into a couple of triangles. That would work out. Okay? Now, again, remember that it's always the lowest value on an integral to the highest. So if we had something like the integral from 0 to b, that would equal negative the integral b to 0, right? Because b is clearly less than 0. Okay. Now, let's say that they gave us some integral 0 to x of f of x dx and said that that was equal to some other function g of x. Okay. And then now remember that f now is equal to g prime. So if I wanted to find a value for g prime of, let's say 2, let's say 2 is right there, g prime of 2, I would go up here to the graph and call that, I don't know, let's call it 1.8. Okay? And now if they asked what was greater, g prime of 2 or g of 2, what you would do then is let x equal 2, and you would find that the area under that curve, which we could say is about 4. So g of 2 then would be greater than g prime of 2. And that's how we would handle that. Now, remember that we have positive and negative area. So in other words, what we're saying is if we looked at this region and that region, right, we could think of the y-axis and this vertical line over here as parallel, right? And this hits in between here, so this triangle and this triangle would have the same area. However, this would have a negative area and that would have a positive area. So if we integrated from a to 0, or 0 to a even, that would be 0 because the positive and the negative would cancel each other out. Okay. Now the other thing is that, remember, the graph is showing the derivative of g. So if it asks where is g increasing, we want the derivative to be positive. So that's where it's above the x-axis. Okay? So it would be from B to C, where g is increasing, because down here, that derivative is negative. Okay. Now, hopefully that isn't too messy, or you can back it up and go back and forth and figure that out. Let's see, what else did I want to talk about? Oh. Let's say that I told you that I had a function that was always increasing. Right? Now, when I think about these things, I think about the simplest function I can. So there's f of x. It's strictly increasing. There's b. It's strictly increasing on my interval. And now, if it said that I was going to do a 20 interval right-hand sum, realize this side of the paper is right, and this side of the paper is left. So what I would do is I would put my intervals in, and then I would be making rectangles out of these things. Now, the question is, would this be an overestimate or an underestimate? Well, this would be an overestimate because we've got all this area up here that we're adding in that doesn't belong there. Okay? That would be a right hand. Now, if we did a left hand, where we went from this side, it would be an underestimate because we'd be cutting our rectangles off like that. Okay? So, that's the difference between a right hand and a left hand. Right? This is strictly increasing. I really suggest, if you have a problem like this, draw it out. Now, they may say 20 intervals, they may say 25 intervals. I mean, you can even do something like, there's my strictly increasing function. There's a to b. Okay? Here's 1. If I do a right-hand sum, I'm going to overestimate. Oop, come on. If I did a left-hand sum, I'm going to underestimate. Right. It's helpful just to look at it. All right. Now, let's see. Was there anything else I wanted to talk about? Oh, yeah. Yeah. All right. Let's say we had a table of data. Okay? Or even if we had a graph. If you have a graph, remember, you can estimate use a right hand sum, use a left hand sum, use a trapezoid sum. But remember, if you're going to try Simpson's rule, you must I can't stress this enough, must have an even number of intervals. Okay. And not only do they have to be an even number of intervals, they have to be the same width. Okay. So if you've got a bunch of them that are 1/2 and one that's 1, you can't use Simpson's rule. So this is why I've said trapezoid rule is a real good one to use. Go ahead and try that. Make sure your arithmetic is right. And that should be enough of a hint, right? But do we remember trapezoid rule? What the heck? Let's go through a little one. X, and let's say feet per minute, X is in minutes, and let's go 0, 1, 2, 3. And let's go 5, 10, 11, 12. And let's say we want to estimate how far they go in the first 3 minutes. So that would be the integral. Here, let's set it up even. Integral 0 to 3, and let's say that's, come on, r of t dt. Okay. So we would say that's about equal to, and we'd go 5 plus 10 divided by 2, and the interval width would be 1, plus 10 plus 11 divided by 2. Again, the interval width is 1, plus 11 plus 12 divided by 2. Interval width is 1. So what are we going to get? Let's take 15, and 21 is 36, plus 23, 36 and 23 is 59, divided by 2 is 28 and 1/2, and that would be feet. Okay, that's the other thing. Remember that if you are given a rate, the integral of rate equals an amount, right? So if you had like how much water was flowing into a tank, the rate of that, if you took the integral, you would get how much water flowed into the tank. Let's see, what else? Anything else I want to talk about? Oh yes, and remember, I cannot stress it enough, before you use substitution to integrate something, you should ask yourself, do I need to use substitution? For example, if I was looking at the test, I don't know that I'd think about using substitution until I got to problem number 6. So, there's some bonus holiday material for you. I hope you enjoy. Have a happy holidays, Merry Christmas, or Happy Hanukkah, Kwanzaa, Solstice, Ramadan, or if you choose not to celebrate any holiday, enjoy the break.